Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled A Collision of Galaxy Clusters. So what do we see here? Well, here we see what looks like a galaxy cluster. And almost everything you see in this image is an individual galaxy. So not stars, but galaxies, which of course are made up of stars, but the actual objects you're seeing here are the galaxies. Now, how do we tell the difference? Well, in an image like this, the stars will get a cross pattern through them because they are a point source of light, and it's called a diffraction pattern that you will see. An extended object like a galaxy won't show that. So while we see these, we can see really these are all galaxies dominated by a large galaxy toward the center of the image. Now what we're really looking at here is that this is part of a collision of galaxy clusters. And it's not easy to see when you look at it in visible light as we're looking right now. But if we look at this in X-rays, it looks quite different. And here we can overlay the X-ray portion on it. And we can see there's a spiral of X-ray emission coming out from the central regions of the galaxy cluster. And this is in a cluster known as Abell 2029. And that is a grouping of thousands of galaxies. So galaxy clusters are some of the largest structures we see in the universe. And that is how galaxies group together. Galaxies tend to gather into large groups. We have smaller groups such as our own local group, but those then join into parts of even larger clusters and superclusters, which make up the largest scale structures in the universe. Now, the gas that we're seeing is very hot gas, extremely high temperatures. That's why it's giving off X-rays. Note, temperature tells us something about the type of light that will be emitted. So a very cool object will emit low energy light, such as radio waves. And that's what we'd see from cooler gas and dust within our galaxy. Hotter objects such as stars primarily emit visible light, although cooler ones will emit infrared, hotter ones will emit ultraviolet. The very hottest objects such as this will emit X-rays, and that's why we see this image taken with the Chandra X-ray Observatory that looks at the X-ray emission from regions around the galaxies and elsewhere. And we can see the structure here, and we interpret that to say how the galaxy clusters actually combined together in the past. So like everything else in terms of galaxies, they combine into larger and larger groupings, which give us the overall large scale structure that we see within our universe. The galaxies, just like galaxies can collide together, galaxy clusters collide together to make even bigger clusters over time. So the process continues, and it ends up that most of the galaxies ended up getting confined into what we call filaments. So filaments are kind of the larger scale clusters on very large scales. And there's filaments and then a lot of empty space between them, voids where there are few or no galaxies. So most of the matter in the universe concentrated into a very small area. So that was our picture of the day, titled A Collision of Galaxy Clusters. We'll be back again tomorrow for the next picture, previewed to be stellar winds. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.